Hello everyone. Let's go on to talk about how to reduce the waiting time for media player. In this video, we'll focus on the HTTP protocol. Up to now, HTTP is still the dominant protocol for playing online videos. HTTP has a long history and is a widely used universal protocol. I am here don't want to show you the history or the specific of HTTP. We also focus on the media player. There are four versions of HTTP protocol you can use to play online videos. HTTP1, HTTP 1.1, HTTP2, HTTP, and HTTP3. HTTP1 provides the most basic function to play a video. And now, in the most situations, you may meet it on a simple local HTTP server for embedded systems. For example, a P2P data servers. HTTP 1.1. The biggest benefit of HTTP 1.1 is the persistent connections. It means you can use one TCP connection to download many files from the same server serially. It's very helpful for playing segmented streams such as HRS and Dash. If your player will support those streams, you should use this feature to reduce the TCP reconnection significantly. Most video applications use one or two CDN providers, which means that most of the videos have the same host name. So the connections sometimes can be reused between the player instances. In this way, you can reduce the waiting time of preparing for play. HTTP2 HTTP2's most important feature is request multiplexing, which means you can use one TCP connection to download many files concurrently. I think this feature is for browsers to download many small files concurrently, such as the images of a web page. And when you play videos, in most situations, the media data have different properties for downloading because the playback is a serial process. So this feature may be not a benefit for the media player. So you should try to avoid using it. But maybe it's helpful for low latency segmented living streams such as LLHS and LL-. And HTTP2 has another benefit for playing a single file media, such as an MPEG-4 file. You don't need a new TCP connection to perform a player seeking. You can cancel the previous logic stream and start a new logic stream on the same TCP connection. And this can reduce the waiting time for seeking. And the connections always can be reused between the player instances. HTTP3. HTTP3 is based on UDP. By now, HTTP3 is not widely used. Maybe it needs more time to develop yet, but some CDN providers have supported it. Some applications use it as an alternative in weak network conditions. And you should prepare to support HTTP3 because it has many advantages. You can get a lower latency living stream playing back than TCP, and more suitable for multiplexing. It supports priority for logical streams, and they don't block each other. Better experience for network switching, such as a cell phone. More efficient than TCP in future. The next feature you should do on HTTP protocol is caching. And caching is part of the HTTP protocol. It was supported perfectly in HTTP 1.1. I think the e-tag info is necessary for caching, and it's been supported since HTTP 1.1. You can cache a media min type file by default because many HTTP servers don't have this command for you. Be different from browsers, media files are larger. Sometimes the media files won't be downloaded fully or from head to end. So you should support this case. And you should manage the capability of the caching files because on some devices, such as a phone, the memory size is limited. Having the caching feature, you can get many benefits. You can use it to do a preloading job. You can resume a playback totally from the caching, like a local file. The player instance can get a larger buffer. It's very good for unstable network conditions, and it can help you to play uneven audio-video interlacing media files. Cicada Player has supported HTTP2 and can simply support HTTP3 by opening the HTTP3 feature of LabCore. I'll finish the caching feature for HTTP with my workmate, but you should wait for the version to be updated to GitHub.